to look at something other than just basically setting building parts, assemblies, and drawings, and basically an extension of a board. And so these are things that you can do automatically. In other words, you can control product. And this is where, in my estimation, this is where we can help out manufacturing. This is where we can actually help our own selves out, and even maybe in some places, and have used this in the past, in my experiences, to actually run virtual product for the sales department. So when I had certain kinds of conditions for products, such as, whether it was trucks or tractors, or maybe it was a combat system type thing, we can actually use the same functionality. We could actually even do it. We even did it at the point of where we could do computer systems, where we had racks and assemblies and master assemblies to actually run what we call an auto configurator behind the scenes. So we can go one step further than this and actually incorporate a layout into it, which then gives us the capabilities of doing manually placement and or automatic placement, but you have to have a layout in its place. But I'm going to kind of simplify it because today's webinar is based upon Pro Program. So it's going to be a little bit more simplified so we can start building from there on out. And as you can see here, and I'm going to kind of more or less expand it all the way open here, I'm going to go ahead and take a look at a couple things here, and that is what we have here. If you kind of look at the actual file, we've got wires. We've got a coil wire, and then we've got a coating. And what happened with this particular customer is they wanted flexibility. So one of the things that they wanted to do is to actually take the coils. They were actually making a 3-conductor or 4-conductor, whatever they wanted to actually do, and be able to actually simulate this as they produced this particular hose. And this whole entire plant, which was located in the southeast here, was actually to the point of where we could actually go through and construct any product that they wanted. But they wanted to kind of simplify it because they had some situations where they had variations that they wanted to see internally. So they had two criteria. One was being the fact of the diameter of the actual hose, and two being the fact of what the pitch was. So in other words, the number of wraps that they wanted to actually see. So you could take and vary the length of it and do things like this. So that being said, we have a lot of things that are happening behind the scenes. As you can see here, we have an assembly, and I'm going to actually go ahead and open that assembly up, because this is where we're driving everything. This is where all this data is being driven from. And one of the big things that we see here is the fact that we've got the parts. We go through all this, and we can see these conductors as we move through. So as we spin around here and kind of look inside of it, you can see kind of the color coding that I actually have. So I've got basically a green, a purple, and then a yellow, where you can actually see all the different wraps that I've got going on. So I've got not only the actual wraps, but then I've got these actual coatings. So as we're putting this together, we're actually winding this on an arbor and then putting this coating on it, because each one of these coatings go over the actual, like a sleeve, and then goes through a basically a temperature, a radiant temperature, and it actually cures all the coatings together. So they have these three coatings that are always on top of these conductors to actually make this particular hose capable. And this actually runs wires through it, so they actually have conduit. And what happens is that they can control a lot of their accessories that they can actually hook on the end of this hose. So sometimes it's a 3-conductor, sometimes it's a 2-conductor, sometimes it's a 6-conductor. So there's flexibility built within this. So in this particular case, they wanted to actually do 3 as being the maximum in regards to the number of wires. So this is what we actually did. And it was kind of interesting because this was set up so that they could actually go through and change whatever they want, and it builds the assembly automatically through the use of Pro Program. Now, there's a difference between the Wildfire series and the Creo series and where it's actually located. in so far as the Creo series, we have to get underneath some of the conditions. So first things first, let's go ahead and take a look at our tools, and then let's get into parameters here to see if there are any parameters. And as you can see, there are two parameters. There's one here called diameter and pitch. So I have a diameter and a pitch that I'm going to constantly be working with. And those two there are something that are going to come through as real numbers as we move through those types of conditions. So we can see what that's all about. Then we can get into a family table. Is there any family tables? No, there's no family tables that are driving anything. So I'm physically taking the product and changing it based upon parameters and parameter alone, as well as my favorite thing to do, and that is one of the things that is key about running Pro program, is the relations. And this is one of the things that I like to actually do. So when I develop all this relationship, this is what's getting written from the Pro program. So I can see that D0 is equal to diameter divided by 2 is equal to pitch. And then for each one of these, I've got comments in here of what's controlling what. So you can see the relations control the conductor. This controls the toting. This controls the B coding. So I'm going between here and here in those perspectives. And then I'm doing the equations and mathematics behind it to actually change this through. Then I'm going through the B and so on and so forth, and it goes all the way down. So these two are the sets that I can actually go through. So I've got A, B, and C that actually is there. So we can see the coding, coding B, coding C. So these are some of the things that we can actually see within that. So these are really functional conditions. So if I look at local parameters here and I expand that, notice the fact that these appear right here. So you can kind of see how the actual relationships actually come into play. So with that being said, we have some situations that we've got to know. One of the things that we can do right away, I'm going to cancel this out. Do I want to cancel? Yes, I do. So I can take a look at some of the characteristics. So the first thing I want to do is I'm going to expand everything. So I get features, everything expanded, anything suppressed or anything else. I'll expand that and ensure I've got everything that I have here. Now, if I come in here and I take a look at a coding, and I can kind of take a look at some of these things. So I've got a surface, and I've got kind of a placement, and then I'm actually thickening this one. So if I go in here and I kind of change this around, I can kind of go through and look at some of the conditions. So these values that I have in here, or parameters, are something that we can actually look at. So if I want to, let's go ahead and just take a look at this particular coding and open it up and see what it's actually all about. And as you can see here, we've got some conditions where we can expand some of those situations. So when we look at this, we've got a section, and then we've got a sweep. So if I take a look at this, I can actually drive this through, and take an edit on this, and we can see that these values of what we actually need. Now, if we go in here and we go into the view, and then we go into tools rather, we can see some of the conditions where we can change some of it. So if we go in here and we do properties on here, we can kind of see what's going on here. So we can change any of these values as we move forward in regards to the naming conventions. And these will control everything that you actually have within these parts. So something like length or whatever. And these relationships are going to start wrapping based upon some of these characteristics that we actually see here. Same thing holds true when you have the diameters and what that actually is. So we can display dimensions and sketches. So it's a little bit different in Creo 2 than what we've seen in the Wildfire series and how it actually looks. So these are some of the examples that we actually see. That being said, we've got some conditions. So we've got some relations, and we've got some conditions up on each one of these wires as we move through this. So how do we get to the fact of looking at Pro program? Well, in this particular case here, I'm going to close this back out, and then we'll get back over here into our our particular assembly here, and it'll take just a little bit here. It's going through a regeneration process to actually see what's actually going on. Now, in Creo 2, we have this automatic regeneration that we can control with our configuration, either on or off, depending upon what we actually see here. So, and here it is fully regenerated again. So if we come in here and we take a look at something called our current program, so we've got into some of the conditions where we can get into some of the properties. So if we go into here, we've got our drawing properties that are actually up here, and then we're actually going to drive these through our model. So I'm going to go ahead and open up our model again in regards to that, and I'll go ahead and open up this physical assembly. So once we get into there, then we get into the actual condition where we get into model properties. And here is where we pick up the program. And as you can see here, this is the line that picks up the program. It's really varied. In order to change this, we have to initiate. So we can actually go into it, and it drops in the screen here. And so what we have here is a set of code. And if you look at what I've done here in regards to the Pro program, what do you see that happens from here on down? Well, all these become a function of what we did in our relationships. So what it does is anything that's in a relationship and we regenerate automatically gets assigned to our program. And so therefore anything that we do with changes such as pitch or such as diameter is going to affect that whole entire assembly as we move forward through it. And it's kind of neat. Now, inside this, I've got some inputs and I've got some outputs. And what happens here is every time that I should be able to hit regenerate, I should get a screen that pops up and says, enter some value. Well, in this case here, I put in diameter space number into the input. And then down below this, I can actually put this phrase, which has to be in quotations, please enter the diameter for the tube assembly. The range, which is what the customer dictated to me, as being between 1 and 1,500 in diameter. So they can start off with 100 as their minimum size and 1,500 as their maximum size. And that was something that was a functional spec that came from their sales department. They did not want to go smaller than that, and they didn't want to go larger than that. So therefore, I put that actually in there. So one of the things that we can do here is I always put a default value. So where I start off with my assembly to begin with is I try to keep this this definition or initiation point at that level. So if something should happen and it's fully not regenerated or whatever the case may be, I can go back to that 250 and it'll actually physically regenerate itself, and then we can actually go through this. So if somebody should actually fat finger it and make the wrong choice and the wrong numbers, sometimes it can happen to us. So this way they can go back to that default, hit regenerate, know that it's 250, and they can recover the whole entire system. So it's kind of neat. Same thing happens to hold true here with the pitch. It should, in realistic formulation, when I go through the program process, it should actually go through and actually estimate this. So these are some of the things that we can actually do. So the pitch space net number should, and then we put this in here, please enter the pitch or the wires. So the wires themselves are controlling the diameter or the pitch as it moves through, whether it's 1, 2, 3, whatever they want to actually do. And so they gave a range between 100 and 1,500. Now, most of the time they don't want this to be the same, so they want this to be a little bit shorter in regards to the pitch diameter as opposed to the diameter, and so on. So we kept it as default. I kept 240 and 250 as some of the numbers that I actually physically use in that. So it's something that's kind of neat in that perspective and goes through that. As we go down into here, you can see what it does for each one of these datum planes and what goes through here relative to it. So it's pulling in all the operations that it needs to actually build the coordinate system, build the planes, and then lastly, everything that's related to that. Now, if I wanted to, I could do something with the components of the wires and so on and so forth as I move through. Maybe I want to change them in, change them out, depending upon, maybe I don't want that in the assembly and so on. So we can put like an auto configurator where maybe we can actually build manually maybe a 6-conductor or a 12-conductor just to see what actually happens. So this is where you'll actually end up putting a lot of that in. And the last thing that you'll actually put into the program is the mass property and if there's any mass properties that you want to actually do. In this case, I didn't, so it just truncates right over the top of it. And because I've got a mass property and an end mass property, it sees it and just keeps on programming through. So these are some of the things that actually goes on in that particular area. So with that being said, I'm going to go ahead and exit this, and we've got some things. It says, do you want to incorporate these changes into the model? Well, we can if we want to, or whatever the value is, so we can actually go through it. Ah, look at that. As soon as I hit yes, and I said, okay, this is my incorporation, it's asking me for something. It says here, current values, enter, or read, or file. So if I have another file that I want to read from, I can obviously pull on that. So I can have many, many, many program files that I can actually do. When I was at Volvo Trucks, we used to actually use this to use the frame rail generator, which actually took and built the frame, all its hole groups, and all the accessories that are actually within that. So it worked really cleanly. And so we could basically build a virtual truck and get sign-off by the company or whoever was buying that particular vehicle. Did the same thing for the future combat system, and also did some things for other companies out in the computer industry and so on and so forth. So I'll expand on this and actually use a lot of the top-down, bottom-up methodology where I can use skeletons because it's easier to replace sub-assemblies into it with that functionality. So that being said, I'm going to go ahead and enter a value. And it says here, so remember when it said diameter number? Well, I've got an option here. Do I want to change it from where I'm at or not? Well, I've got an option of whether I want to change this, so I can check this number, or maybe I want to just see where I'm at. So I check both of them. I want to see where the actual pitch actually is. So if I say done select, it says please enter the diameter for the tube assembly. That's interesting. So notice that that comes across as being something that comes in our pull-down menu for our conditions that we want to be building this diameter and assembly. In this case here, I'm going to use, let's say, 300. And then I'm going to hit enter. And now it goes to the next one. And so as I go into the input and end inputs, I can go down and ask a series of questions. So it would be like if I wanted to pull in something like material, mass properties, whatever I wanted to actually do, I could ask those questions and you'd have to respond to it. The user has to respond to it. And then when you're completely satisfied with all the questions, then it goes off and does its own thing. So in this case here, we have something that's relatively simple that is going through. In this case here, I'm going to use 250 as its pitch for the wires. So we'll see what actually happens when I hit enter and see what happens. Now you can see it's going through regeneration state. And so consequently with that, we can see that situation. So that being said, it's still trying to regenerate here. It'll take a little bit for it to regenerate. So I'm going to close this back down here. And as you can see here, it's changed the way this actual part is. So as we go in here and we close this back out, notice the fact that now the assembly has changed. Now what we're drawing and reflect exactly what we want to actually do. And as you can see here, this little X down here and everything else that's going on, now it's fully regenerated, because now it's going to change and go from red back over until you actually hit some of the areas of green. So you can see what can actually go on until it finally, if there's something that happens, you can kind of see that situation will actually be shown and put in place. So that being said, we can always go in here, and if we want to find the regenerate, we can actually type in regenerate. And I love this window because you can actually see what it says. Regenerate active model. Ah, there we are. We're under review, regenerate active model. So we can actually see that. Then, oh, wow, look at this. This all changes too as well. So by going to automatic, now I'm back right where I was actually at. So I can actually do pitch and diameter and say done select. And here, now I can click the 400. Now I'm at the drawing level. I'm no longer at the assembly level. So what's happening here? We have a parent-child relationship between the part, the assembly, and the drawing, and they're all talking together. And if I change that over to 400, I change this one over to 300, and now it's going to go through the regeneration process, and you can kind of see what will actually happen. Notice the big red X down here. That means it's going through its regeneration process, and it's going through and changing all the wires, the wraps, the coatings, and the assembly so that it can report back those new diameters. And we should see some wraps here in just a minute here once it pulls through this regeneration. And now we have it regenerated in its full form. And you look at it, it's like, well, nothing really has changed much. Well, yeah, our diameter has changed in a lot of the dimensions that we actually have here. Notice the fact that we've got a cross-section up here of this, where these wires and conductors actually are. They wanted to see those particular conductors in its form, in that perspective. So we can do it, and it's really interesting. And once you get this set up, then it's just a matter of hitting, okay, let's hit regenerate. Now I can go back right into automatic, and I can say, okay, what are the current values? And what it'll do is it'll report back what those current values are. And then when I go into regenerate again, now I can hit automatic and hit enter. And I can, maybe I don't want to do one. Maybe I just want to do the diameter. I don't want to do the pitch. I can actually go back and say, okay, there's my current dimension right there, 400. That's what that's actually reporting back as. And now I can go back over here and make it as 600 and say, okay, done. Now it immediately goes in and regenerates because I've only checked one of those, and it's actually going to go through a regeneration process. And you can see it should actually grow this by quite a significant amount. So you can take parts, assemblies, drawings, and any of your fixtures that are related to this and cause it to grow right with it. It's a great thing to do so far as what I call a top-down, bottom-up methodology, where you can control this assembly and you can control this through Pro program to actually allow these parts or assemblies to be generated through the use of skeletons. And, yeah, it's still in the regeneration process. So these are some of the things that are going on in that particular area. And you can see now it's really grown with that size. And so these are some of the things that you can look at and kind of get into play. Some of the things that we can also take a look at here in regards to some of these features. When you look at the actual feature itself, you can see that there was a layer. There's these layers that actually overlap. And what was the real short to this whole thing was when we built this, we always had to have one wrap that always overlapped each other. So if this was, let's say, a 3-conductor and width for that particular coating, or 2-conductor or whatever, then we always had to make sure that we had a double underneath so that they could see that in the cross-section. And that's what I did by actually color coding this with all these different colors. So you can see the double overlaps where here you have a single overlap. And so you can see that as it wraps through that cross section going forth, because that's the way they truly did it in manufacturing. So it wasn't until we actually cut this particular hose laterally and actually seen that, it wasn't there until I picked up and said, oh no, our model is completely wrong, because we're not getting the overlaps that we're seeing from each one of the coatings that we're actually going around. So we changed that, and that's what we ended up with, and it works fine. And then when it's fully done and regenerated, notice it's gone back to the green state. So, message to the wise in regards to Creo 2 is always pay attention to that little stop sign down below, because there might be something that hasn't regenerated or something that has been frozen. And you can tell this real quick by what we call the actual tree columns. So if we go into tree columns and then we go up under status, you can actually see exactly what's been regenerated and what hasn't. So it's a really cool situation in regards to that. So you can see these conditions. And it doesn't matter. This is relatively simple, but yet somewhat complex, because what I did here for each one of these wires, in the particular the coatings, they were actually swept sections. And so therefore, when you go through this, you can vary that, and then you give it its length. So kind of a neat thing to do in regards to thinking about things you can do with Pro program. Now, I've done things like where you go into let's say a server tower, and you have maybe multiple bays where you can actually pull in and out the actual servers, where you actually have like a whole big case where all these servers are located in a server room. And you can actually swap out. Maybe you have 1, 2, whatever. You can swap out the whole thing by actually setting it up. Now, the next thing that you can actually do that's actually better than this, and that is that you can bring a layout into it. Now, layouts have to regenerate. For the first time in Creo 2, since Wildfire 5, we now recognize the layouts, and the layouts themselves work hand in hand. So I can put these in as values or parameters and get this to actually drive these actual products. So kind of neat in regards to what you can do with product and how far you can go. This is a high-end CAD system and will work very well as an enterprise solution. And this is why I've spent as many years as I have in it, because there are no boundaries here. There's no limits. I see the limits when I just see people using drawings, assemblies, and parts. Because they're only taking up 10% of what their full capabilities are. When you see something like this, where you can program something like that, you can actually get it to affect your packaging people and the people that put together your product that you ship on a daily basis. And this is where I see a big advantage to this type of condition, is where you can actually go into that. So these are some of the things that you can see. And for cosmetic standpoints, just so that when I go into here, I've actually colored these overlays so you can see when I create the cross-section what's what and how they're actually overlapping each other. So these are some of the things that we really worked on. So kind of neat, kind of different, but those are some of the things that you can think about when you get into the Pro program sides of things and what actually goes on here. Now, the thing of it is that you've got to remember, if you go underneath File and then you go underneath Prepare here, you are not going to get, under the drawing options, you are definitely not going to get anything to do with the Pro program side. You physically have to be in the assembly in order to get that. Here you can see that that's not the case. So I have to go back in here and recap this to open this assembly up, and now I can actually physically see that and what's actually going on. So these are some of the things that we can actually look at. And then from there, then I can go under File, Prepare, and come up on the Model Properties. And it's very, 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 very subtle to actually see this. Now, in this case here, I don't have any interchange groups. But if I had an interchange group, I could incorporate that into my program and use my skeletons to drive those interchange groups. or basically what I consider a sub-assembly. A good example of that would be like, let's say I have a tractor and I have engines, transmissions, bodies, hoods, three-point hitches, whatever the case may be with all the functions on it. Each one of those groups become a function of a master, and that master actually is that subassembly called engine relative, or transmission relative, or whatever I'm working on. Maybe I'm working on a drivetrain system. So, or maybe I'm even flipping the other side of that interchange. Maybe I'm pulling out servers in a server rack. And so each one of these server positions have those types of conditions. So it's kind of cool in that perspective. It's local. So that's where you're going to get into a lot of that. And then once you get into this, now you actually have, this is what I'm talking about, the input. That was the diameter number, and it has to be these relationships. You see how this diameter is here? This has to be here. So when I see this diameter coming up here, it sees those actual values and what's going on. And one of the comments I actually like to do is to basically say, hey, I'm going to make a comment, who wrote this program? And so I'll embed usually somewhere in this place. This one is at the top. But a lot of times when I get into a really massive program, I'll bury my name 2 or 3 times into it, then maybe delete the first line or whatever, just to you know, claim some ownership. Because in case somebody questions it, what are we doing here, and how are we getting some of these characteristics of pitches to actually happen? So these are some of the things that go on and go through these types of situations. Okay. And then once we're all done, we're happy with everything. We can do file exit, and then it'll actually go back into this particular part, and then we can actually do whatever. We haven't made any changes to it, and so therefore we can just close it out. If you want to incorporate it, and this is your choice, whether you want to or not. I can say no here, and now I can close this down to actually get out of the program. And then I can close this back down. So you can see how these actually come together in that perspective. All right. That being said, any questions?
I'm not seeing anything so far, Bill.
I haven't seen anything. But these are some of the things. If anybody wants to run through this, you can take a recording of this and kind of walk through this thing. I am more than happy to help whoever wants in regards to an assembly and get you started off in that thing. The big thing is, and I can tell you, while we wait for see if anything happens in regards to questions here, is that you make sure that the assembly regenerates. So what I will do before I write that relationship is I will make sure that that assembly, if I'm changing one of those variables called pitch or called diameter, that whatever that range is, it's going to regenerate. Now, in some cases where it doesn't, then you'll know where those ranges actually are, and you have to know what those situations. And I, by all means, when I'm changing variables like this, I want to know where I can recover all the time. And that's what we call massaging the model. So.
Looks like we do have a question.
Okay.
It says, can you make the drawing to scale the views, the fit, the drawing template automatically? Oh, and he says, can you make the drawing to scale the views to fit the drawing template automatically? Sorry about that, Andy.
Yeah. Yes, I actually did not use a template here to actually cause these two, so I could blow these up where everybody could see what was going on. So the answer is yes, you can use a template. I did not in this case because I wanted to blow them up. Any other questions? The other thing that you can also do too when you actually get into a table form, particularly with an assembly, and this is something that I worked through earlier this week, is if I have a table, let's say if I have a family table and I have variations within that, I can actually bring in that family table and all those parameters and populate that dimension with a repeat region that sits within that table. So if I want to change out and say, okay, I want conductor A to be, let's say, 3 millimeters, and then conductor B to always be 6 to 20 millimeters, or whatever those ranges are, I can actually put that within the family table and fill those out. And then what I can do is I can have letters called out on the print so that that table means something when you actually get to that particular print. One of the big things that I can tell you from experience is that when you get into parameters, the parameters drive everything in regards to program. So if you happen to miss one of the letters or something along the program, it'll actually not allow you to fully get out of it, and it'll actually pop up that screen again and say there's an error within the program that doesn't understand parameter or whatever. So you can actually see that as those conditions happen. So if there's no other questions, anybody else have any questions?
There is another question from Andy. If you need to modify the design and it changes one or more of the variables, is there a simple way to update or edit the program to update the variables?
Let me see if I can understand this. It's got it coded up here. You need to modify the design and it changes one or more of the variables. Is there a simple way to update, edit the program to update the variables? I'm a little bit confused with that question. I've got variables there. I've got pitch and diameter. I can vary it all the way through. When I hit regenerate, and it's my last variable, then it actually comes through there.
Andy, if need be, if you have a microphone, I can unmute you so you can speak. I just unmuted you, Andy.
Can you?
Andy, go ahead and ask the question.
Can you hear me?
What I'm not understanding here is you've got one or more variables. You've got two variables, and they want to update or edit it based upon those. And I'm doing that, but I'm confused.
What I'm trying to ask is sometimes let's say in one of the parts, one of the geometry needs to be changed. Let's say your circular wire becomes a rectangular wire. Then I would have to delete my diameter and change it to two vertices, which I need to dimension. This would completely change the variable in the program. In that case, I would have to reprogram it from scratch, or is there a simple way that I can update the geometry?
There actually is a simple way you can actually update the geometry, and that is that you take that wire, let's say if I take that wire and make it round to square, I can have that as a variable within my family table and call upon one of those in my program. Do you want a square or do you want a round? I don't have to even reprogram anything. You can just add that right into the input.
But
I want always just being a square or always being a round. Or maybe I want to change that diameter to that, and then you'd have to add that relation. The key is the relation has to have that, not the program. The program will actually see it. That make sense?
Sort of. That means I really have to incorporate all the variables up front. I cannot go in to an existing design and change something, change the geometry without touching the program or reprogram it to quite an extent.
That's correct. This is what we call a master assembly. So when you look at a master assembly, it has all the features within it. And then your output to your drawing is going to be your specifics of what you actually have, whether it be 400, 300, square, round. Maybe I have it hollow, for that matter. There's all kinds of things I can do. And where does that come from? Why do I like to actually look at that? And this is where a lot of companies go wrong, because out of sales or whoever's controlling that product that you're trying to ship, they're going to have some functional specs of what they expect that product to do. And then you can incorporate that within your product. And you can actually ask the engineers what those actually are. And in this case here, what I did was I used this to actually control a manufacturing facility and just let the engineers put in those numbers that they needed to make their lives much easier, so that they could actually, the manufacturing engineers could do their normal jobs. So, yeah, that's a very good question. Thank you.
Thank you.
That is also why I'm, Andy, you just hit on a very good reason of why I'm a big fan of master models, and also the fact of the use of top-down, bottom-up methodology to have everything that the customer wants at the top level. So, good one. Good one. Anybody else? Rosalinda, do you see anything else?
No, I don't see any more questions. And keep in mind, you can always send questions to me, and I can get those to Bill as well, if you come up with some afterwards.
Well, with that, guys, I really appreciate you attending the webinar and all that. And like I say, and like Rosalinda says, if you need to get a hold of her, please ask away on any questions. Try it. See what happens. Start small and let it go from there. There's nothing like the real thing of getting it to happen, because you learn so much from it. I know the first couple times I did Pro program, it was like, wow, this doesn't work. This doesn't work. Oh, yeah, now it's working. And you get all these variables and everything. And you can find out what's going on within the assemblies, and you kind of basically massage them. And I'm just a real big fan of actually producing the product in the manufacturing world, so us in design can actually work with the manufacturing engineers so that we can output the product faster to the customer. And that's the ultimate goal, is do basically in today's format is doing more with less. And this is a good case of doing more with less. And we in our engineering backgrounds that we actually have here, we are tasked with so many things today. This could be a good solution in regards to having something run in the background, where we could almost do like our jobs and then be able to support manufacturing or anything that's going on that's coming at us. So it gives us hopefully a little bit more freer time to actually work with it. That being said, everyone, thank you for attending, and I appreciate it. Any questions, please let me know.